All right. What's up, guys? We're going to start our graphing of trig functions. And I know you guys messed around with this the other day with the activity that I gave for you on Desmos and then the discovery thing on Delta Math. So hopefully you kind of got an idea. But what I want to do is go through the actual process of how I want you to graph sine and cosine from like here on out. Okay? All right. Your basic sine curve. Now, you guys, this all comes from, and we're just going to be using like radians, okay? These points. So 1, 0, 0, 1, negative 1, 0, 0, negative 1. And we know that sine is the x coordinate. Okay? So as I'm going around here, look, check this out. At 0, the x, sorry, I said sine is the x coordinate, I meant y coordinate. Okay. At 0, sine is 0. Pi over 2 is 1. Pi goes to 0, 3 pi over 2 is negative 1, and then 2 pi goes back to 0 again. And we have this curve. I mean, we could sketch every point in between, right? Pi over 6, pi over 3, pi over 4, but we kind of know what this looks like. Then we just go through and we follow the pattern on the other side too. Okay? That's your basic sine curve. All right? Now, the way that I want you to memorize how to do this, because you guys know, like, I'm really not all about memorization, right? I really want things to just kind of like make sense in your head so you don't have to. If you just remember your first point, okay, this is how I remember it. Sine starts at 0, and if A is positive, it goes up, and if A is negative first, it goes down. So it starts at 0, right? Positive would go up first, negative would go down first. Okay? But that's the big thing I always memorize is sine starts at 0. All right. Now, what we're going to be doing in a little bit is, well, first, let's go ahead and change the amplitude and the period. Okay. In front of sine, we have A. Sometimes we can put a letter in front. We have B. Okay? Now, A and B represent the constants that are in those positions, right? Okay, the amplitude is the absolute value of whatever A is. Because technically, amplitude, it actually means the height of the sine function, like specifically from what's called the midline, okay? I'm going to draw like just like the midline of this, which kind of goes like right through the middle. All right, you guys see that? So that's the midline. And it's like how far up and how far down it goes from the midline. So like up 1, down 1. Okay? Your basic graph is just 1. So as I change that number in front, it's going to change the amplitude, right? So A can be a positive or a negative number, but amplitude should always be positive because it represents the height. All right, sweet. The next thing we have is the period. Now, B. The letter B actually tells us how many full cycles this will make in a 2 pi period. Okay? So, if B is 4, it would make 4 cycles in a 2 pi period. If B was 12, it would make 12 cycles in a 2 pi period. Okay, but here's what's a little bit easier that I want you guys to remember for the period. 2 pi over B. That's your period. All right, that's one full sine function. And one full sine function goes 1 up, 1 down. Okay, so that is called the period. Okay, one full sine function. One cycle up, one cycle, like 1 up, 1 down. All right. Okay, now I want you to do this in a very specific way. Okay. So if I say, like on here, all right, A is 2, B is 1/4. So that's good. A, B. Well, the amplitude is the absolute value of that, which is 2. The period is 2 pi over B. So if I do 2 pi over 1/4, well, that's the same thing as saying 2 pi times 4 over 1, which is 8 pi. Now, the way we're going to do this when we graph is we're always going to label it to one full period right here and right here, okay? So whatever you get for your period, all right, I want you to label that here and here. Okay. Then we actually want to label, now you don't always have to label every single one, but for now, while we're getting used to it, I'd like you to. We're going to label all these. All right. You guys look, this one right here, that's half of 8 pi. Half of 8 pi is 4 pi. And then this one's half of that. Or you can do a fourth of 8 pi, or you can do half of the middle. So that's 2 pi, right? So this is actually 2 pi, 4 pi, 6 pi, 8 pi, and then the negatives, I'm not going to label every single one. They follow the same thing. So this helps me label the x-axis, and we always split it up into 4 parts, okay? All right, then the amplitude is what helps me label the y-axis, right? So if it's like 2, like I'll just put like 2, -2. I mean, if it was something like 40, maybe I'd go by tens, right? Okay? And now we go like this. All right, it's a sine function, starts at 0, and because a is positive, it goes up first. 0 up to the amplitude, 0 down, 0. It just looks exactly like that. So because we kind of changed the labeling on here, right? It looks like a regular sine graph, but that's the way that it's labeled. Okay? Okay, cool. Let's look at another example. So this one's a little interesting. So, okay, I have A and B. So A is -3. That means that the amplitude is the absolute value of that. So the amplitude is actually 3. Okay, the period is 2 pi over B. Okay, so this is kind of interesting. So 2 pi over B crosses out. So the period is actually just 2. So that's okay. I can work with that, right? Remember that on the x-axis, we're labeling it out to here, here, and then we're dividing it by 4. Now, if you want to just go straight to divide that by 4, you know, like what's 2 divided by 4, and that's 1/2, you can do that. If instead of doing that, if you prefer to say, okay, half of 2 is 1, half of 1 is 1/2, that's fine too. And then I just label them out. So it's like 1/2, 1, 3/2, 2. So my x-axis on this now doesn't have pi on it, but that's because B was pi, okay? Okay, and then the amplitude helps me label this. I'll just go ahead and go up 1 more to 3, down 1 more to -3. Like if it goes off the graph, just adjust your labeling or whatever too. Okay, check it out. This is a sine. It's going to start at 0. Negative means it goes down first. 0, -3, 0, +3, 0. Okay, and then reflect it on the other side. All right, so really, I mean, these look like the same. What the heck happened here? Okay, these look this very similar. One's going down, one's going up. All right, and their heights are different. But other than that, just because of the way that I labeled it, you know, the graphs kind of look very similar. Okay? Okay, sweet. Let's take a look at cosine. All right. Again, if I go back to 1, 0, 0, 1, -1, 0, 0, -1. Okay, and if I talk about like, all right, cosine is the x coordinate. All right. So at 0, it's at 1. At pi over 2, it's at 0. At pi, it's at -1. 3 pi over 2 is at 0, and 2 pi is at 1. All right, check that out. That is one cycle of the cosine curve. Now I come over here, and I just do another cycle, okay? And so, yeah, what you want to remember for cosine is cosine starts at A, right? So it starts at A or the amplitude, right? And then the way I think about the next one is if A is, okay, if A is positive, this actually makes more sense saying it this way. It starts at positive A, goes to 0. If A is negative, it starts at a negative and goes to 0. Okay, so whereas sine starts at 0 and goes to A, cosine starts at A and goes to 0. All right, that's just really, that's the key to remembering the difference between sine and cosine. All right. Okay, so same exact deal though. This is all exactly the same, right? The amplitude is still the absolute value of A. It represents the height from the midline. The period is 2 pi over B. B represents how many times it cycles between 2 pi. Okay? All right, sweet. Let's take a look. Okay, so let's look at this example here. Okay, A is 4, B is 3. So this has an amplitude of 4. And this has a period of 2 pi over 3. Now, this is tricky, honestly. But again, if you guys do this like the exact way I tell you every single time, if you follow these steps, it's not going to be that hard. All right? So amplitude 4, you could go by 2s if you want. It might be easier. As long as you label it, do whatever you want. Okay, remember, one full cycle is going to go to 2 pi over 3, negative 2 pi over 3. Now, I have to cut this into fourths, right? So I basically need to take that and divide it by 4 to figure out what that is. And that doesn't go very nicely, all right? But that's okay. It's actually fine, because what we can do is we can go like this. 2 pi over 3, and I want to cut it in fourths. Okay? Think of that as like 4 over 1. So that'd be the same thing as saying 2 pi over 3 times 1 over 4. And if I reduce that, 2 goes into 4 2 times, it's pi over 6. Okay? So that's 1 pi over 6. That's 2 pi over 6, which reduces to pi over 3. That's 3 pi over 6, which reduces to pi over 2. And then that's 4 pi over 6, which reduces to 2 pi over 3. And so it all works out. You just have to be kind of careful about, okay, so like dividing by 4, and you might have to use fractions and then just like following the pattern. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then just reducing as you go. So once you get it labeled, like the rest of it is like chill, okay? We go like this. So cosine starts at A, goes to 0. So one full cosine cycle is that. That's one cycle. So it's just like a big down and a big up. All right? Mirror it on the other side. Big down, big up. Okay? All right, hopefully that makes sense. Like the fact that we're putting all this into a, like we're going to label the axes ourselves should make this a little bit easier. Okay. All right, check this one out. Let's see. We've got, all right, 1/2. So I'm going to use amplitude as a half. And again, I mean, put it wherever you want. I guess if you wanted to like show that it's a really short one, you know, you could put it right here if you felt like it. But honestly, I'm going to just use my lines here. So as long as I label it, right, 1/2, negative 1/2. Okay, now, what the heck? This is crazy. All right, remember the period is 2 pi over B. So 2 pi over 4 is the same thing as 2 pi times 4 over pi, which is 8. All right? So that means this goes out to 8, negative 8, and I cut it in fours. 2, 4, 6, 8. Who do we appreciate? Ms. Mitchell! Yay! We're gonna have to work on that. I didn't hear you guys saying it out loud. Come on now. 2, 4, 6, 8. Who do we appreciate? Okay. Cosine starts at A, and because A is negative, it's going to start down here. Follow my pattern here. So just as one big loop, de-loop. Same thing on the other side. Okay? Easy money. Am I right? Easy money. Okay, now we're going to start doing some shifting. So this is going to be some vertical and horizontal shifts. All right? Okay, you guys, check it out. The A that is in front for both sine and cosine right? That's the amplitude, and the amplitude is the absolute value of A for both of them, okay? All right, the B that is right here, that's how many times it cycles in 2 pi period. So the period is 2 pi over B. Now this other part, you guys will remember this from regular transformations. We talk every time we do graphing, we talk about transformations, right? Left, right, up, down. Okay, inside here, all right, the C, this is like left, right. Okay, so that's your horizontal shift. Okay, so that's the C, left, right. And remember, it's the opposite of what it says. So for example, if it says -2, we're going to use 2 to the right. Okay, so if you guys remember that. And then we have D out here, which represents our up-down shift. Same on both, okay? Represents our up-down shift. And basically, if it's positive, it's up. If it's negative, it's down. So that's represented by the letter D in my picture. And this one is same. We do not do opposite. Okay? I didn't write left, right on here. All right. Now, there's one other thing that I want to show you before we just like kind of dive in here. Okay. This number, we actually don't want it there. We can't have it there. We need it to be out here. And the problem is, all right, it's not like we have a textbook or anything, but if we did, a lot of textbooks will write that number in there. It's like, that's annoying. And then I was also looking at like Delta Math. I was looking at some other like online, generators, the thing I used to make our worksheets, stuff like that. And a lot of times it'll have it in there. It's a little annoying. One little step that we're going to do is we're going to bring it out, okay? So if you happen to see it like that, we're just going to move it out. Now, by factoring out that 2, so listen to what I'm saying of factoring out, it's taking that out and putting it here. But I also have to factor it out of here, right? So it says we're factoring out a 2. Factoring out means the same thing as dividing by 2. So if I take this and I divide by 2, okay, so think about it again, dividing fractions, it gives me pi over 4. So the way I'm actually going to write this is x minus pi over 4. Okay, on your homework, I tried to just have it in this form. So I don't think you need to do that, but just in case we come across a problem and you're like, what are you doing? Like the B needs to be outside. Okay, now everything from here on out should be smooth sailings. Okay, check it out. My amplitude is 3, because it's the absolute value of A. My period is 2 pi over 2, so that's pi. Right now, before I do anything, I'm going to go ahead and label 3 and pi. All right, and if I label this stuff in the middle, I go, okay, I need to divide pi by 4. I can do that in my head because that's pi over 4. So it's 1 pi over 4, 2 pi over 4, I can reduce that. 3 pi over 4, I can't reduce that. And then pi. Okay? Cool. You don't have to label the negative side if you label the positive side. That's all right. Okay, now how does this shift? Okay, look right here. So inside is left, right, and it's opposite. So negative pi over 4 means it moves right pi over 4. And so, well, actually, okay, hold on. Before we do that, though, let's actually just draw my graph up to this point. So once you do, actually it says it right here, label the amplitudes and the shifts on the graph first, like say what they are, right? Label the units. Sketch the basic trig function with only amplitude, period, and vertical flips means negative. And put it as a dashed line so you know that's not like your final answer. Okay, check this out. I know that this is a sine graph. So sine graphs are going to go 0, 3, 0, negative 3, 0. And, well, I'll do this. I'll go ahead and do the same thing on the other side. And I'm going to use a dashed line, because this is my final answer. Some people like to use dashed lines and dotted lines. Some people like to use different colors or like highlighters, like whatever you want to do. Brilliant, right? So at this point, I want you to draw it with a dashed line or like lighter or something like that. Then we're going to come down here. We're going to go, okay, cool. I move everything right pi over 4. Now you got to look at your label for this, because like, well, what is pi over 4? That's why we label all these. Pi over 4 is 1 square. You guys see that? On my label, it's 1 square. So I need to move everything right 1 square. 1 square, 1 square. So I'm going to go through here, move everything right 1 square. Man, I really should have done that in a different color. Let's do that again. So it stands out a little bit more. See that? There we go. Okay. And I usually just, you can do one of two things at this point. You can just continue it off the graph there, because that's 2 full cycles, and that's totally perfect. I'm good if you want to do that. Or if you want to keep it all in and fill this in, you could do that part over there. So like either one, right? And there we go. Okay, so your steps are, you graph it with a dashed line with the amplitude and period, label everything, graph it, and then you move it left, right, up, down. Okay? Okay, let's practice one more sine graph here. Like, what the heck? This is crazy, right? This is crazy, but just gonna go through the steps, gonna remain calm. We got this. Okay, check it out. I need to bring this out front, yeah? Because, again, if you see it written like this, I'm not going to try to do that on homework or tests or anything like that, just if you see it written like that, right? The way I'm going to give it to you is going to be already factored out. I didn't put a lot of vertical shifts on here. I need to go back and do that. Okay. Anyways, let's just say that this has a +1. Can you guys write that in? Let's just say that has a +1. All right. If I take out a 2 pi, so what I'm doing is I'm taking 2 pi out of there, which is just giving me x, right? And I'm taking 2 pi out of there, which is giving me a 2. So that's giving me x plus 2 plus 1. All right? Cool so far? So I go like this. My amplitude is 3. My period is 2 pi over b, which is 1. So my amplitude is 3. That's 1. That's negative 1. All right. Divide that by 4. Divide that by 4. So I'm going to get 1/4, 1/2, 3/4, 1. No pi's, nothing like that. Okay? All right, nice. Now, at this point, I'm going to graph this with a dotted or dashed line, okay? That's what I do at this step, so I'm not even thinking about the shifts right now. I'm noticing this is a sine. Sine starts at 0, goes to A. Now, A is negative. You guys see that? A is negative, so I need to go down first. There we go. All right. Cool. Okay, now it's time to make my shifting. Let's use like a different color so it'll stand out a little bit. All right. This is going to go left 2, up 1. Now, looking at the scale here, left 2 is how many boxes? For 8 is actually 8 boxes to the left. Okay? That one's up 1. Up 1 is how many boxes? Well, because that one's going by ones, it's just 1 box up. All right, let's talk about left for a minute. Oops, let me start here. Left 2 means I go 1, 2, 2, 1, 2, 2, 4. Okay, that point goes to there. Left 2, that point goes to there. Left 2, that point goes to there. Left 2 goes to there, and then left 2 goes to there. Okay, now look at this real quick. Okay? And then what's going to happen as this pattern continues? All right? Then the next one is going to go like that. And then the next one is going to go like that. Do you guys see? Hopefully this makes sense. We'll talk about this more. But left 2 does nothing for us. Right? And sometimes that happens. If the shift left or right is a multiple of the period. Okay? So I mean, if you don't understand that, it's okay. Some of you don't get that. Like, if the shift is a multiple period, it means like a full period and then a full period or something like that. This is basically just going to come right back on top of itself. You know? Oops, let me get this back drawn again. Okay. So the left 2 does nothing. Now, the up 1, that's going to do something. So then, since I know that it's the same, then I'll just go ahead and make each of these go like up 1. Right? And each of these like points, I'm going to do up 1. Okay? So the up 1 is cool. Yeah, you know what? Anytime that you want to like take a look at this, actually, you guys, let's see here. You guys know that I love Desmos. Okay, so, sorry, I was saying, you guys know how much I love Desmos. Like, let's look at this question, just really quickly. Let's look at this question. So, we started out at -3 sine. Oh, I forgot to put y equals on Desmos. Okay, y equals. Now, right now, I'm only going to put in the amplitude and the period. 2 pi x. Okay? Why does it not like that? Oh, it wants another set of parentheses. Okay. Whee, doggy. That's crazy. Now, remember, though, that, okay, when we were labeling the x-axis, before I had it going like -4 to 4, really, I just wanted to go like -1 to 1. That's what my full period was, and step was 1/4, right? By 1/4. So you guys see that? Okay, now let me zoom out a little bit. Okay, now look at what happens when I take this exact same equation, all right, in a different color, right? But what I'm going to do is I'm going to put plus 2. You don't see a difference. Plus 1. You don't see a difference. Now, if I went by plus a half, okay, now it moved like over a space. Or if I went plus 3/4, it moved over a little bit. But when I go plus 2, it's literally the same graph because it's not really making a shift at all. But then when I go ahead and put plus 1 at the end, it moves that graph up 1. All right? So we'll work on a little bit more of this stuff later. This is just kind of an intro thing here. Okay. Cool, cool. 1, perfect. All right. Okay, let's take a look at a couple more equations here. All right. Let's see here. Okay, cool. We're on to cosine now. Okay, check it out. We're going to rewrite this as, if I bring the 2 out, I'm going to rewrite it as this. 4 cosine 2, and then it's x minus. Now, if I'm dividing both these by 2, I get pi over 2. Okay? All right, so check this out. My amplitude is 4. I'm just going to go up to 4 because why not? Okay, my period is 2 pi over b, so that's just pi. Pi divided by 4 is pi fourths. It's pi over 4. 2 pi over 4. 3 pi over 4. That one can reduce. Okay, so there I go. All right. Now, before I do any shifts, let's go ahead and draw this as a dotted line. Now we know that cosine starts at A, goes to 0, right? Okay. So there's my cosine graph. Nice. All right. So when I go to shift this, okay, it looks like this one is going right pi over 2. Now, if I look at this graph, okay, pi over 2 is 2 boxes to the right. You guys see that? Because it's like pi over 4, pi over 2. Okay? So I'm going to move this 2 boxes, 2 boxes, 2 boxes, 2 boxes. Okay, as soon as you can get like kind of a idea of the pattern, you just go on and, you know, again, once again, you can either keep going like that, which would be fine, or I like to just fill it in over here. Okay? Now, what's super interesting about this is like moving it right pi over 2 is the same as doing what in this case? It's the same as flipping it upside down, right? So moving right 2 boxes is the same as taking the original one and flipping it upside down. So there's always multiple ways to write these things. All right, does that make sense? Okay, let's look at like this one already. All right, this one's already written out good for us. Let's see here. The amplitude is 2. The period is 2 pi over b, which is 4 pi. So I'm going to go 2, 4 pi. And then I'm going to go pi, 2 pi, 3 pi, 4 pi. Cool, cool. No shifting. This just goes up 1. All right. Okay, so I'm going to draw it up to there without the shift in it. I'm going to do it dotted. Okay, and I'm going to say, okay, cosine. Now, this is -2, though, which means it starts down. It goes 0 to 0, -2. Okay, and then the only shift that I'm going to do on this one is make everything go up 1. And again, I can just kind of follow this pattern. Make sense? All right, now this is like, what are some other equations that I could make that would make this do the same thing, right? Okay, so I want to take a second. Let's go back to decimals really quickly. Okay, so we're doing -2 cosine, and let's see, 1/2 x. I should use 0.5. Plus 1. Now, obviously this looks a lot different than what I had because my labeling is like way different, right? Okay, so this time I was going from -4 pi to 4 pi by pi. And then on my y-axis, I mean, I'll just go like -4 to 4. By once. Cool, cool. Check that out, right? Okay. Now, what's another way that I could write that exact same thing? Well, check it out. Don't change, right? I'm going to actually see if I can write this as a positive cosine. Now, as a positive cosine, but how do I move that point over to there? Or like that point over to here? You see what I'm saying? Well, I'd have to shift it by like maybe, I don't know, -2 pi. Nope, that was too much. Minus pi. Hey, look at that. I shifted it by pi, and now these are totally like matching up, right? What if I took this same thing? Okay. So here's my original one. What is this saying? -pi, and I shifted it left pi? I went plus pi. my gosh, same thing, because a minus pi shift and a plus pi shift are going to kind of line up to be the same thing, right? Okay. Interesting. All right. Let's see. Actually, hold on a sec. Yeah, there we go. That's actually out here. Okay. So basically what I'm trying to tell you is there's like multiple ways. We won't list these all right now because I know this is already getting a little bit on the hectic side here, but there are multiple ways to rewrite these same equations by shifting things left and right. Okay? All right. Let's look at this one. All right. Amplitude. Okay, so my amplitude is 3. My period is 2 pi over a half, which is 2 pi times 2 over 1, which is 4 pi. So I'm going to label this. Okay, 3, negative 3. This is a sine graph. Sine starts at 0 and goes to A. All right, so I'm going to go ahead and sketch my original graph here. Okay. Nice. Now, the shifting that I'm going to do on this, oh, none. Cool. No shifts. All right. But what's like another graph that I could make this same thing? Okay, you guys, let's say I had, let's just like see if this makes sense to you. Okay, this graph that I just drew in yellow, that is a cosine graph. How can I tell? Because it starts at A, right? It starts at 3, and it goes to 0, negative 3, 0, 3. It's got the same period as this one. But how do I take this yellow graph? Let me actually draw it in so you guys can see this. Okay, how do I move that over to that one? Right? Well, by moving it right one box, which in this case is pi. So by moving it minus pi. Okay? Now, what if I took this same thing and instead of moving it right, I moved it left 3 boxes. So then left 3 boxes would be plus 3 pi. And you can kind of keep making the same graph over and over and over again. And you can use sine or cosine. It's just whichever way you think it makes sense, okay? Yeah, I could call this a negative sine graph instead of a positive sine graph and move it to the right a couple spaces or to the left a couple spaces. So because they're like cyclical, it kind of is how that works. Okay, here we go. I think this is our last one we're looking at. Sweet. Okay. Let's see here. So my amplitude is going to be 2. My period is going to be 2 pi over b. We haven't done many vertical shifts. Can we just do a vertical shift on this one? Let's go like down 1. Just add that in because we haven't done a whole lot of these yet. Okay. If the amplitude is 2, the period, okay, so 2 pi divided by pi over 2 is times 2 over pi is 4. So I can do 1, 2, 3, 4. Okay. For this graph, it's a cosine graph, so it's going to start at 2 and go to 0 first. Oh, I think I'm supposed to be dotting that, right? Okay. So let's kind of dot this or whatever I got to do. Boom. And I did that one too low. There we go. Okay. And then I'm like dotting that. All right. And then the only thing that this wants me to do is the only shift is like down 1. So if I just like move everything down 1. Okay. Not too bad, right? And again, there are like other ways I could make this. I could write this as I'll just give you like one example. I don't want to get into this terribly much, but let's say I started with that as my starting point. That's a sine graph. It goes up first instead of down first. It's a positive sine graph. It still has an amplitude of 2. It still has a period of pi over 2. Okay? But it's moved. And the way like I would have to move that point to get to, let's see here, right? To get it to that point, because we're going up 1, or yeah, down 1. That's not going to change. But we'd have to move it over by like a space. And 1 space here is 1. All right? It's a little bit tricky if you can kind of follow my logic on that, right? Now, the last question, just really quickly. What if your x-axis is labeled for you? Okay. Well, I mean, that's going to be really difficult with a question like this because we're only trying to go to 4. But I guess, I mean, for me, I would say, dude, just relabel it. You know? Because it's really tricky, especially here, but like something like this where it's 4. Okay, so look at this question right here, where it was like 4 pi and negative 4 pi. Well, if I have to put this in, you know, if I had to put it as a 2 pi, okay, and I couldn't change the labeling, well, I would just look at this and say, okay, 2 pi is here. So I would just draw like 1 big part there, 1 big part there. Okay, so you just kind of like have to change the scaling basically. Alrighty. That is definitely time. Let me just show you a little bit on your homework so that you guys don't get too confused here. Alright. Let's see. There's the homework. Here we go. Okay. So for each thing, I want you to write the amplitude. Remember, that comes from A, period. If left, right, up, down. If there's not, just put none. Okay? You're going to label this yourself. So for example, on number 1, the period is 2 pi over 1/4, which is 8 pi. You're going to label that yourself. And then you can just do those in between. So just like label that. The amplitude is 3, so just label that. Okay? And then just draw it. Sine starts at 0, goes to A. Whoops. Go over quite far enough. Okay. Boom, boom, boom. Doom, doom. What am I doing? It's late. But anyway, you get the idea. Do the same thing on the other side. All right, so just kind of like follow the patterns I made. You got like 3 sine, 3 cosine. Now these are a little tricky. Okay, these are all in a 2 pi period. I just want you guys to try it. I will show you one and we'll see if you guys can get the rest. Now, there are going to be multiple answers, but here's what I like to do. Okay, start here. It starts in the middle. That's a sine graph. It goes up first. That's positive. The amplitude is up, down. It goes up 1, down 1. So the amplitude is 1. Okay. Now, remember I was telling you, like, 2 pi over b is the period. But what b really is how many cycles it makes in a 2 pi period. Check this out. Count this with me. That's 1 cycle. That's 2 cycles. That made 2 cycles. All right. Now, as long as you always start in the middle, you won't have to make a left-right shift. So that's cool. I'm not going to even need to make one. But the last thing that I want to show you is there's something that we should talk about. It's called the midline of the graph. The midline is if I cut this thing right in half. You guys see that? Now, normally sine starts at 0. This starts at 1, which means that this is up 1. Okay, and I need to put y equals because it's an equation. But basically this midline right here will always tell you what the vertical shift is. If the midline's at -4, shift is -4. If the midline's at 10, shift is 10, plus 10. All right, so you can kind of try these and see if this looks like a sine because it starts at 0, goes up. This looks like a cosine because it starts at A and goes to 0, right? This also looks like a cosine. One of them's positive, one of them's negative. So just see the best that you can do. All right. So it's a little long. I know you're not going to be able to finish the whole thing during class, but really appreciate if you guys keep up so we're not too far behind when I get back. All right, friends. Have a great day.